Everybody, so we're going to solve some equations today. So last time we saw how to work with algebraic expressions, the properties, and simplifying them. So today we're going to basically solve some equation. As we talked about, I mentioned before, when we introduced equations, we only checked for solutions. So today we will actually solve them. Going to solve all sorts of equations. So first define equations. Start with a lot definition, then let's see how to define all sorts of equations. So when we say a linear equation, we mean an expression with an equal sign. As we saw before, so an equation is like this, or it's an expression basically, and we add an equal sign to it and some other sign. So that's an equation. It's got to be an equal sign. We usually have an unknown number, an unknown value. Could be one variable, could be more. And basically we try to solve or find that number, try to find the missing number. Last time we just checked. I gave you some numbers and asked you to plug them in and check. But today we're going to actually find the answer ourselves. It could be something as simple as this or something longer, as we're going to see later. So here clearly, so here what it means is a number we don't know added to 1 is 3. Apparently that number is, the number must be 2. That's right. So this is a solution. This is a very simple equation. We can check it. We can check if it works. So if you plug it in, we should it should work. We should get a 2 equal numbers. So 2 equal values. So if you plug 2 here, we'll get 2 plus 1 is 3. We say, is it equal to 3? We'll plug 2 here instead of x, we say, is it equal to 3? That's how we check. Then you simplify both sides. This is a simple equation, so 2 plus 1 is 3. This is 3 also. And that's it. So we just solved this equation, one solution only. And it took basically one step to solve, and we got the solution. So that's basically what linear equations are. It's going to be x. In one variable, it's going to be x and one variable to 1 power. So generally, they all look like this. All the first degree equations, they have some x, some number here, some number after. Just like here, for example, we have 1 and 3. Here it could be b, could be c. And the power of the x is always 1. That's why it's called linear or first degree. Because of the 1, we call it linear. Or we can also call it first degree. Okay, so there's going to be one unknown number, and the power of that number would be 1. That's why we call it linear or first degree. If anything else, if it's like power 2 or 3, it's a different equation, different name, but we're only going to talk about first degree equations today. So it could be basically as simple as this, or maybe longer. Might be longer with, for example, more variables, maybe even parentheses and so on. For example, this, or maybe something like this, or with parentheses like x minus or plus 1 minus 6, for example, equals 12, and so on. We're going to do all these and even some longer ones, with parentheses on both sides. So maybe an expression like this on both sides, and we'll see how to simplify and solve each one of them. It's all based on basically what we did last time when we simplified expressions It's basically, this is an expression. The left side here is an expression. We're going to simplify it the same way we simplified equations or expressions last time. And it will make it easy to solve here. Well, hopefully we'll turn them into something simple like this. So that's basically just a little definition, introduction to linear equations. Now, let's actually see how to solve these. So the way this works is pretty simple. So we'll go back to the first one here. Let's see how we get that solution. So when you have an equation and you have an x in it, so you try to find the value of x. You try to basically isolate the x. Isolate the x, get it by itself equal to something. And to isolate the x here in this one, I'm just going to get rid of the one, the positive one. If we cancel the positive one, we will have x by itself. And whatever is on the other side will be the solution. So how do we cancel this positive one here from this side? How do we
translating it to the other side with a different symbol?
Okay, that's one way.
When you translate, and it will be negative one.
You're breaking up, Marjorie. You sound very unclear.
Oh, okay.
Can you fix your sound? Yeah, can you fix your audio? Okay, so we can either move this over, or we can just cancel it from here by doing the opposite of it. Remember last time we did the opposites? So we do the opposite of this, so we can cancel it. So a number and its opposite, as we learned last time from the properties, they cancel each other out. You can have x. And whatever you do on one side of the equation, you also do it on the other side. If you subtract from here, you're going to subtract 1 from here also. So this will be 2. That's basically where the 2 comes from technically. This is the actual step. Maybe we did it in our heads, but this is exactly how you get to it. So equations could be simple like this with 1 step. Or they may take 3 or 4 or 5 steps, as we're going to see. The longer you get, the more steps they will take. So this is a one step equation. Let's see now what happens if you have something like this. A little bit different than this, but you may take more steps than that one. So now, in order to isolate the x, which numbers need to be canceled in order to get the x by itself?
4 and 2.
Minus 2.
Minus 2
4.
and 14.
Exactly. So we need to cancel the negative 2, cancel the 4, then you will have the x by itself. Once we have the x by itself, we're going to look at the number, whatever numbers this becomes, because this will change based on what we do on both sides. And we will have our solution. Let's first cancel the negative 2. How do we cancel that?
With a positive 2 next to the 14. So you add the 14 with 2, I think.
That's right. So we're going to cancel this by combining it with its opposite, because that cancels them out. And again, whatever we do here, gotta do the same thing on the other side. So that cancels, so we're going to end up with 4x. And these cancel out and combine whatever this is, 14 plus 2, that's 16.
Mm-hmm.
Good. We need one more step to get the x by itself, to cancel the 4. So how do we cancel the 4 here?
Put in the 4 divided with the 16 in the other side.
Okay.
Like 16 over 4.
So to cancel the 4, because we have a multiplication here, this is 4x or 4 times x. We're not going to do negative 4. It's not going to work. You have to do the opposite of multiplication, which is division.
Mm-hmm. So you divide up.
That's right. And divide both sides by the same number. So this is
4.
also, that's right. Also, this is, you can think of it as the reciprocal or the inverse property. So basically 4 and 4 cancel out. It's like multiplying 4 by 1 over 4. Or dividing 4 by itself, that cancels out. And x will be 4. Okay, so solving is basically isolating x. Only cancel the numbers that are with the x. We don't care about the number on the other side. The numbers that are with the x on the same side, we need to cancel them So we can get the x isolated like this. So that's our solution. And this took us, what, 2 steps. So this is a 2-step equation. Okay, 2-step equation. So the longer it is, the more terms, the more parentheses and numbers you put in it, the longer it will take. So then we'll do another one. Let's look at this one here. This time it has parentheses and so on. So let's do that. So this may take longer than the other two. Again, remember the purpose of all of this. Purpose of solving is to get the x by itself here. X equals something. That's the purpose of this. We got to do whatever we have to do, simplify and multiply until we get the x by itself. Okay, so what is it that we do first here?
To do the distribution.
Distribution, that's right. So basically, if you look at the left side,
Multiplication and distribution.
that's right. So the left side here is basically an expression. So we're going to simplify it the same way we simplified expressions last time. So if you have parentheses, you want to distribute first before you do anything else. So it's going to be 3x plus 3. So distribute or multiply. This is a multiplication. Bring down the -6, bring down the 12. Okay, what did we do last time again after distribution? What do we do?
Yeah.
What do we do after distributing?
We're going to
The subtraction.
We combine like terms, right? So what do we combine? What do we combine here to simplify? Basically, we're just working on the
3
left
and
side to
6.
simplify it.
This is
That's right, +3, -6. +3 or +3 minus 6. What is
It's
that equal to?
-3.
-3. That's right. Again, the rules of addition and subtraction, we apply them when we combine. We apply the rules of multiplication when we distribute. So all the signs we'll learn again, they're very important. And this is where we use them. Or just an example where we use them. Good. Do you see now that we simplified it? It kind of looks like this. The form of it kind of looks like this. Also looks in standard form. So all the equations practically look like this. So you have ax, the a here is 3, then we have some b is -3, we have some c, the c is 12. This one also, same thing. They all look in the standard form. So we cancel b, we cancel a, so that should have x by itself. So what do we do next here? What do we do next?
Add the 12 with the 3 on the other side.
Okay, so we need to
And-
cancel the -3. This -3, cancel it, and then cancel this 3. How do we cancel this -3 again?
With a +3.
The positive, always the opposite. So they can cancel out, as we learned last time. That cancels, so we can have 3x. This 3x left equals this 15.
15 and then over 3.
That's right. So the final step now is to cancel this 3. Again, we do not subtract it. We have to divide because of the multiplication. So we're going to divide this by 3, divide this by 3. So x is 5. And that's the solution. And you can always check it. You can check this by plugging it. Basically, you plug the x here and use the order of operations to simplify. Let's actually check it. Let's check this one. Usually this is something you do on the side just to make sure you got your correct answer. So we're going to plug the x into the equation. Replace every x if you have more than one with this. So it's going to be 5 here instead of x. We're going to put the possible solution because it could be right, it could be wrong. You could have made a mistake here, adding or subtracting. So we can easily make a mistake. Always double check. Always check your answer and see what works. So 3 and x here is 5 plus 1. The rest stays the same. Only change this, but everything else will stay the same. And we say here, because we're checking, we're not sure yet, we say, is it equal to? Is this, when simplified, is it equal to 12? So if it turns out to be equal to 12, then this is valid or true or correct. If not, then you have to do some double checking and see what works and what doesn't. So when you simplify now, we should start from here because this is, we don't have x here, so we use PEMDAS to simplify. So obviously we're going to do the parentheses first. That's 6. We have 3 minus 12. Again, we say is it equal to 12. What else we do? According to the order of operations. So what is the next operation here to simplify this? Minus, this is 6, right?
Yeah.
This is 6. Right? So this is negative 6. It stays the same. We only add these two. Now, what is the next operation?
18
You multiply the 3 and the 6,
multiplication.
which
So
is
that's
18.
18.
Exactly. So we'll do the multiplication first and subtraction. And again, we're going to say, is it equal to 12? Finally, subtract these two. That's 12, 12. And as you can see, how it works. So this is value. But again, you could easily make a mistake. So make sure you check your solution on the side and make sure it works. Check your signs. Usually a sign mistake like this can make the answer wrong. And also when you simplify, when you distribute and combine like terms, that's important. Make sure to get everything right so you don't change the equation. The equation is still the same. Maybe you change the form of it, you simplify it, but it shouldn't change. You shouldn't change the value of it. And that's pretty much what we're going to be doing over and over again for a few more problems. Any questions so far, everybody, about any of these problems? Everyone, please make sure you understand these before we move on to the next ones. Questions? All right, let me give you another one. So this we checked here. Let's maybe make this one a little longer. Or before this, maybe a different example first, and then I'm going to do something longer with parentheses. Sometimes you could have this. You could have an equation here that has x's on both sides. As you can see, we have x's on both sides of the equation. We also have numbers on both sides. But we can also solve this. The purpose again is to get the x by itself on one side here equals to a number. That's the purpose of solving. So what do you think we need to do to solve this, to get the x by itself? Everybody, how do you do here?
Shouldn't you do what you do, kind of take that 5 and put it by the 2? Cancel out the 2?
That's one way to do it, but also we have x here. So
Oh yeah, you have your like terms, so you want to combine them. I didn't see the 4x.
combine them. Okay, how do we combine them? How do we combine them? Do we just add them, or do we do something else? Or
You're multiplying the
grouping.
5x, it's 4x.
okay, so I will say it again, just one at a time.
Aren't you
Are you going to
multiply them?
the 2 first, the same time? You go
A grouping like the terms that are equal, and when you
Similar.
move both similar, yeah. When you move like sizes, the one size to the other, you will have to change the signs.
I will
Okay.
pass 4x
That's
to
right.
the left and the -2 to the right. That's what I would do.
That's right. That's right. So basically, when you see numbers and x's on both sides, first, if you have any like terms on, combine them. If you have any like terms, combine them. If you have any like terms here, combine together, just like we did here, on the same side first. Then, if you after that, if you have no like terms to combine, if you have no,
positive 2 under the 2, positive 2.
That's one way. That's
Positive
right.
to the
So
question.
you're breaking up. Your audio is breaking up. Whoever is talking, you have very bad audio. Please fix it or mute yourself.
Professor, you will have 5x minus 4x equals to 3 plus 2.
Right. So this is what we need to do here. Since we have x's on both sides, we need to have them both on one side. So what we're going to do is we're going to move this over. Before we can just combine it, we can't just combine 5 and 4 right now. This has to be moved here. And also, we're going to combine this with 3. So we're going to move it
No,
here.
that will be 1, x1, x equal to 1.
Yeah.
That's right. So it'll be 5x here. And since we're moving something to the other side of the equal sign, we have to change the sign of the term. So this term here is positive. It has an invisible positive here. We move it over, becomes
For x,
negative 4x.
negative for x.
Then we do the same thing here. So we're going to move the negative 2 back here. So if you move it, it becomes
We're gonna
Positive.
positive,
positive 2.
positive 2.
So we
So-
move both at the same time. So this is convenient and it saves us time. You can still do it one thing at a time. You may add 2 here as we did earlier. You can add 2 here to cancel this and add 2 on the other side. And then you will have to do minus 4x here and also minus 4x here. That's like 2 steps. But if you move them at the same time,
That will be 5.
it's 1 step. So 1 step is better than 2 steps. And this is easier, and you don't have to think about whether to add or subtract. Just move things around, then combine them. That's after you simplify each side. If you have parentheses or something, distribute first, combine like terms here on the other side, then combine. Now we can combine these. So 5x minus 4x. That's
1x.
1x. That's right.
Okay.
And 5.
5. 1x is the same as x. No need to
X.
divide. That's right. This is just x. No need to divide. And this is, of course, 5. But if you end up with another number here, for example, 2 or 3, you would divide by that number, divide both sides. But with 1, you don't need to. 1 times x, as we saw last time, is basically x, because 1 is the identity of multiplication. So that's what you do if you have x's on both sides. If you have x on one side only, like here, if you have x on one side only, you just need to cancel this and then cancel this. You may still move the negative 2 if you want. You can move it. Becomes positive 2 and combine it with the other one and then divide. But if you have at the same time you have x's and numbers, if you have x's and numbers, then you do both at the same time.
Professor, can you go up and show me the screen, please, real quick?
Mhm.
Up, up, up.
Okay. So
Thanks.
so now, so that's important. So now, a lot of times you will have also parentheses on the other side. So we have parentheses here, x and parentheses here. So before you move things around, before we do this, we would have to simplify each side like this. Each side, distribute, combine like terms, make it simple. Same thing on the other side. And then we do this. So don't do this until you combine. But for example, if you have any similar term to x or to 2 on this side, you're going to combine them first before you move them around. Let me give you an example of that. So you may see something like this. And minus maybe maybe 6x here. And on the other side, you may also have something. Parentheses also numbers, so you could have maybe negative. Let's see here. Negative 3, maybe x plus 2, and minus 4. See, that looks like a long equation. There's a lot going on here, but we basically we're going to do the same thing we did here. Just going to simplify it. It's a little longer, but the steps or the method is the same. So the main idea here is to, before you move things around, so you don't want to move anything else yet because you have parentheses. We got to clear those, got to combine like terms. So before we move anything around like this, we got to work on each side, each expression here. We're going to simplify this completely, simplify that one completely also. And then maybe we will do that. So let's work on this side first. What do we do first on this side to simplify?
Parentheses, the distribution.
That's right. So the distributive property, just like we did last time, think of this. So ignore this for now. You just ignore this for a moment. Focus on this left side. So it's an expression. Again, not addition first. You got to distribute first. 5 stays the same. Positive 4 times 2x. That's 8x.
8x
And
minus 4
minus 4.
minus
And
6x equal to minus
right.
3x.
That's right. Then on the other side, also going to start doing the same thing. I'm going to distribute parentheses and see if we have any like terms. So this will be
Minus
negative.
3x
Minus
minus 6 minus 4.
Minus 4. That's right. Back to this side now. What do? We combine like terms. So what exactly do we combine?
we combine x
5
with
and
the
4.
plus
Combine the x's together and
x. Mhm.
the numbers together, exactly like we did last time. And on this
Positive.
side,
X positive for x. 1,
we have positive.
1,
Well, let's start with these two. 5 minus 4, that's right, 1. Then you have positive 8 minus
Positive.
6. Both have x.
plus for x. Positive for x.
We combine these two.
X,
Positive 8
2x.
minus
Put 8x
Mhm.
minus 6x plus
right.
3x.
And x, 2x.
No, what are we
Because
combining?
I moved my all the x to the left side.
So simplify first. It's better to first work on each side, completely simplify it, so you don't have to move many terms. Now we're going to simplify this one.
Minus 10.
Marjorie, your audio again is really breaking up, and it's keeps breaking up. So try to fix it, or I don't know, but it's really annoying. Marjorie, try to fix if you're using headphones, maybe change them or something. Breaks up.
Okay.
I only hit 1 word out of 5 you say. Okay, so please fix it first and then come back. Again, back to this side. What do we combine? Everybody?
6 and 4.
4.
You add
Yeah. Negative
6
6
and 4.
That's right. Negative 6 and negative 4. This stays the same. There's no like term.
Positive 10.
Not positive 10, but
Negative 10.
negative 10.
I was thinking. Oh,
All
there
right.
is distraction.
So first, before you move, you don't want to move too many things at the same time. Move all of these and move all those. It's going to be a lot of work. Work on each side first. Make it simple. Now it's much simpler. It's easier to just move one thing now to each side rather than moving a bunch of things here and a bunch of things back here. So work on each side first, simplify. Simplify. Now it's much simpler, as you can see. Kind of looks like this. We're going to do again what we did here at the same time. So what exactly happens now? So what do we do here now? We have x's on both sides, numbers on both sides, just like this one.
Now we can move, right? So
Okay, so what
or
moves,
cancel the 1 with a negative 1.
or we can move at the same time. Just
Or
like
we
did
can
here.
move.
Okay, so I'm gonna move this over to combine it with this. And also we can move this to the other side. This we can do at the same time. You can still do -1 and do -1, and then you will have to do plus 3x and plus 3x, but it's 2 steps. It's easier to move the x's to one side and numbers to the other at the same time in one step like we did. So this becomes 2x. The negative 3x moves to the other side of the equal sign next to this. Negative 3x becomes
Positive 2x.
1x.
That's right, positive 2x. And the 1 moves to the other side. The 1 here.
Negative 9.
That's right. So this is a
Positive
positive 1. It moves to the other side. Becomes negative 1. This negative 10 stays the same. The 1 moves over. Becomes negative.
Oh, that's 11. Negative 11.
Will be negative 11. So we're going to combine these. So that's 5x and minus 11. Okay, so simplify each side first. We did. Then move x's to one side, numbers to the other side. These are the 2 main steps. One last step here. one last step to get the x by itself. What do you do?
Put the 5, 11 over 5.
We need to divide both sides. Going to divide both sides by 5, so we cancel. We
5.
cancel the 5, it will be negative 11 over 5. So even though it was a long equation, as you can see, but it didn't take that long. It took us one step, 2, 3, 4. 4 steps in a very long equation. But again, remember the main things, not the detail. Remember that you need to simplify each side. Basically, when we say simplify each side, we mean combine like distribute, combine like terms. First, so before you move anything to any side. And number 2, basically, you're gonna move the x's or the x to one side. And the numbers, if you have numbers, you gotta be on the other side. And the numbers to the other side. Okay, so that's what we did. So the first step, simplified, we got this, then we move things around. Finally, we isolated the x. You may have to divide. Sometimes you don't have to, like here, but here you have to divide to cancel the 5. So the last step is to isolate the x. Okay, so these are your 3 main steps. Doesn't matter how long the equation is, break it down into 3 main steps. Again, work on each side, simplify it, combine like terms, distribute. Do the same thing on the other side. Combine like terms again before you move things around. Combine like terms, the equation becomes much simpler here. Once you get here, if you have x's on both sides, move them to one side. Also move the numbers to the other. Combine, then isolate the x in the last step. So you're basically using the. It's important to know your signs, of course. If you don't know the signs, it's going to make it much harder than may seem. It's not actually hard, but if you don't know the signs, it will make it even harder. And also, basically, we're combining or we're using the properties we learned last time, the order of operations. So we combine all that together to basically isolate the x by itself. Okay. Any questions about particularly this problem, everybody? Pretty simple problem. We didn't do much there. Any questions about it, everybody, before we do another one? Okay, so let's maybe look at another one here. Again, let's put some parentheses on both sides, x's and so on. Make it a little complex. So maybe 3 x plus 4 minus 7 on the other side. You may also have some parentheses. So, so let's say, for example, 4x minus, let's see, 4x, and we're gonna combine this with maybe 2x. Okay, so again, this is the longest equations you will probably see, or maybe that was the longest one. But again, it shouldn't take that long. Steps are here, the example is here. So what do we do again first? Everybody? What is the very first thing we do?
Distribution. Oh,
That's right.
the distribution multiplication.
So first thing is to simplify each side. We're gonna work on this by itself, work on this by itself. So distribution first. 6x plus 12 minus 7 and what exactly happens here?
Distribute
Okay, what exactly do we get?
4 and 8, I mean, that is 8x.
Why 8? Where do you get the 8
The
from?
4 and the 2, right? I mean, not 8.
4x and then minus 2x.
So this
So it's gonna
we're
be minus X.
distributing. Okay, so we're not distributing the 4x. We're distributing this minus over. Or this thing of it as minus 1.
Oh,
Okay, so this is not it's by itself. So we're going to distribute the minus first. So it's going to be 4x here. So negative or negative 1 times 2x, that's negative 2x. What else?
Plus 1.
Plus 1, that's right? Negative times a negative is plus 1. Okay, so we're still working on each side. Back to this side by itself. Again, we're not moving anything yet. What do we do here now on this side? What needs to be done?
Simplify.
combine the like terms.
Okay, so what do we get?
Subtract 12 and 7.
And that
Um,
is
So 6x and what do we get if we combine these? Everybody,
5.
what is that?
Positive 5.
Positive 5. Back to this side, also we're still working on it. We're not moving anything yet. So what do we do here specifically?
Subtract 4x minus 2x. That will be
Okay,
positive 2x.
that's right. So this will be 2x, bringing the positive 1 down. Good, so we did this step. First step is done. So we simplified each side on its own completely. Now, what happens next?
Change the places, like I don't know how to say it in English, sorry.
Okay,
Put
just
the
move.
x together
That's
on
right.
the left
Gonna
side.
move. We're gonna move this over, move this over. Move the x's to one side, the numbers to the other, just like we did here, just like we did here. And so that will be a 6x, 2x moves over. Everybody, what does that become if you move 2x over?
Negative 2x.
Negative 2x. And move the positive 5
And then
over.
1, positive 1 next to the negative 5.
So the positive 5 moves over, becomes, positive 5 becomes negative 5. The 1 here stays the same. Then we're going to combine these two together. That's 4x. And here, this will be
4.
Negative 4.
negative 4. So it's going to be negative 5. All right, one last step here. What do we do?
Divide.
Divide by?
Divide
4.
And divide both sides by 4. By 4. X is Marjorie, you're still having the same issue. Marjorie, you have some sound issues as always. You're breaking up again. I don't sound robotic. I can't hear what you're saying. So please again keep your mic muted until we fix it. Okay, I really can't hear you. Only can hear like 1 word out of 3 or so when you say so. All right, so the answer here is negative 1. So again, as you can see, it doesn't take that long. 1, 2, 3, 4. 4 steps. The longest one here also takes 4 steps. So this is what you need to remember. These main steps. Of course, your signs are very important here. Order of operations, the properties of exponents, the properties of expressions, and the real numbers that we learned last time. And you can solve pretty much any first degree equation. Any first degree equation you can solve easily. Okay, any questions, everybody, about any of this? Everyone, any questions about any of this, or especially the last few problems, the longest ones? No questions? All right. So if you guys don't have any questions, I give you a few to do by yourself now. As you can see, we've done a bunch. Same steps every time. Okay, there might be 7 or 10 problems. I'll let you do a couple. What a few by yourself. But let me know if you have any questions before that. All right, so maybe one of each.
Yep.
So say maybe negative 3x plus 6 is negative 12. So watch your signs carefully, okay? Signs are important, so I'm giving you all sorts of signs here. And also maybe negative 15 here. And if 4x is another one, and maybe a longer one. Say 10 minus 2 plus 4x. And the other side also, maybe some parentheses and another expression. So let's say negative 3x. This one minus 1 plus 5. And that pretty much sums up everything. Again, the longest one here doesn't have to be complex. It's almost, there's an identical problem here. And the other ones are even easier. This is the longest one, which will take you 4 steps, but the other ones even less. Okay, steps are also here. All right, give you a few minutes to work this out. Before we discuss this together again, talk about the homework afterwards and any questions you may have. All right, so I'll give you about 10 or so, 10 to 12 minutes to work on this. You may also take a short break if you wish to. Take a short break, then start on the practice. And when we come back, we'll go over this together. Okay, I'll see you in a few minutes. Everybody, are we done?
I am.
Okay,
Yes.
Yes.
okay, good. Everybody else? Finished?
Yes. Yes.
All right.
Yes.
Okay, sounds good. So let's try. I'll go over these together. For the first one, what do we do first? Here,
We transfer the 6 to the right.
so we cancel the +6.
Mhm.
Cancel, so we can have -3x
Mhm.
equals
Negative 18.
-8. That's right. Then we divide
Divide to 3
by
By three.
-3. So
Yeah,
we
negative.
have
Negative 3.
-18. So we're going to divide basically by the same number we want to cancel. We want to cancel -3, so we're going to divide by -3. Also here, divided by -3. So x is
6.
6. That's right. That's 6. That's it. So solution is 6. Next one, what do we have to do here first?
We're going to simplify. Look,
What do
you're
we do
going to
first?
the multiplication. Combine.
The
You're going to
distribution.
Combine it.
the distribution.
So we're going to distribute first 5x minus 5 minus
Okay.
10 minus 15.
Mhm.
Then I combine these two. So what do we get?
-15.
15.
Yeah,
Okay.
negative.
Right. 5x
Mhm.
-15 and -15 also on the other
15.
side. All right. What else?
You combine the
Now
two.
we translate the -16 or we cancel the -15 with the
We
+15.
cancel.
Uh-huh.
Okay, so
So
cancel this.
No,
Cancel
no,
this,
no,
so
5x
5x.
equal to 0.
X again.
And then it's gonna be
You divide by you
5 by 5 is gonna be 0. Isn't it gonna be x 0 though?
X
No,
equals 0.
x will be, yeah, so divided by 5, 0 divided by 5 is 0.
Okay, so yes, I got that.
This is 0. And the next one here. What do we do here? A quick one or 2 steps. What do we do first?
Cancel the number 1 with the -1.
4x.
Since we have x's and numbers on both sides.
The x's
what do we-
together.
Put the x's together and move this over. Also move this over. What happens if we move something to the other side? What happens to it?
Negative 2x.
That's right. So the sign will change. So -2x. The plus 1.
Yeah, equal -3
Okay. And the +1 becomes.
-1.
-1
And so this turns into 2x.
or x.
-4.
That's
-4.
right.
Divide by
No, y tú me dijiste-
positive
me
2.
dijiste anoche que-
Divide
That's right. Finally divided by 2 by 2, so it will be -2.
2.
-2.
Okay, so if you have x's on both sides, move x's to one side, the numbers to the other at the same time. You can still do -1, -1, then do -2x, -2x. It's better to move both at the same time. The longest one here again should be pretty simple. We take off to also maybe 3 steps or 4. So what is the main step here? Main big step.
Distribution first.
That's right. So we're going to work on each side. Simplify each side by itself first. Simplify this before we move things around. So, and the very first thing here, what do we do? Distribute, not subtract yet, not subtract, and distribute. So 10 minus
¿Cuánto tú necesitas?
-6x.
-2 plus,
plus 4x.
okay, then we go to the other side and do the same thing. We're going to distribute. So what we get?
3x.
That's right. So negative times negative would be positive
Then
3x.
negative 1
Uh,
plus
That's right.
5.
sí.
Negative times positive 1 is negative 1 plus 5. Back to this side again, simplify it more if possible. So what do we combine? What do we
The
combine here?
The
x's
negative.
negative
Yeah.
2x. We put
Okay.
the and then we made a subtraction and
And also,
we got
this,
an 8.
so we have 10 and negative 2, which is
8. Positive 8.
would be 8. And then you have negative
Mhm.
6x plus 4. Negative 6x plus 4 is,
You said
Mhm.
negative 6 plus 4.
that's right, negative 6 plus 4 is,
Negative 2x.
negative 2x. And back to this, to the other side. What do we combine here?
The negative 1.
Negative
and
1
positive
plus
plus the 5.
it's a subtraction, so it's
It would be
4 positive 4.
Would be positive 4. Good. So now it kind of looks like this problem. So after we simplified the whole thing here, now we're going to pretty much repeat the steps again here, and we should get the solution after that. So what happens?
You're gonna come back.
Happens again. We're going to move what moves and where?
The 3x
The
to the
3x
left
to your left.
turns in a
To your
negative.
right. I mean to your left. Yeah, sorry.
That's right. Move this over. It changed the sign. And we're going to move this over
eight.
also. Change the sign. So the negative 2x stays here. So this is a negative term, stays here. This becomes negative 3x. On the other side, the positive 4 stays here. We're going to move
Negative
8.
8.
That's right. A positive 8. This is a positive invisible plus here. It moves over, it becomes negative. We combine these two together now. Negative 2 minus 3 is,
Isn't it that negative 5?
that's right, negative 5x. And these two here, if we combine them together, what do you get?
Negative 4.
Negative 4.
That's right. So it'd be negative 4 here. One last step. What exactly do we do?
You're gonna cancel out, so you're gonna make it a positive 5x. And then whatever you do to your left side, you bring to your right side.
That's one way to do it. Or what the operation? What's the
I could
operation?
divide it.
Negative
Division.
5x for over positive 5x.
What do we cancel? What do we cancel?
No,
out?
The negative side.
Luisa Maria, you have a lot of background noise, so please make sure next time it's quiet, or you mute your mic next time in your next class. The whole time you had some noise in the background. We have to do one specific step, one last step. We need to divide by
The
this,
negative.
just like we did. Yeah, just like we did here. Just
I
like we did
said
also
that.
here.
So we're not
That's right.
dividing the negative 5 from the positive 5?
That's right. We divide.
Right.
By the, not by the positive, by the negative, by itself.
Okay.
Okay. So we want to cancel this, we divide it by itself. So negative divided by negative. Also here by the negative, because we want to cancel it. We divide it by itself. So x is negative divided negative. We saw before that it's positive. So this is positive 4 over 5. And we try to reduce it. It's okay for the answer to be a fraction. That's not a problem.
Okay.
Just try to reduce it, simplify it. Could be a positive.
Would it be
a
wrong
negative,
if it's a
0.
decimal?
No need to, unless you're dealing with decimals in the equation, if it's a decimal equation. But usually this is fine. Just reduce to reduce basically the answer to the lowest terms if it's a fraction. Okay, everybody, any issues, any questions about these solving equations? As you can see, it's pretty simple. There's about 3 steps. And again, the signs, it's all about the signs. So review your signs, make sure you know them well. And yeah, all the operations, the properties we learned the last time, all those little properties of commutative, associative, identity, all those little ones, that's basically what we used here to kind of simplify these complex equations, something as long as this, into something simple and easy like that. So that's basically how we apply those properties, not only into expressions, but into solving equations. And we will see them also. We'll see them again and again in other topics in the future. So you'll find the homework on Blackboard. You'll find the recordings also of the lectures if you guys want to rewatch.